Guess what it's time for? More calculus. Woo! So in here it says, now that you know the big three would be the product rule, the quotient rule, and the chain rule. What? Wow. Chain. And by the way, if you want to know how to spell wow, I think it's something like that. Wow. This is where you have a function within a function. Quotient is you've got a fraction of some sort. Product is you've got multiplication. So let's do this. This might combine all of them together into one. Yes. And look at how much room we have to write. So much. The first thing that I'm going to do is rewrite f of x equals, and instead of writing x, or square root of x plus 3, I'm going to rewrite this as x plus 3 to the 1/2. Because now I can see that I clearly have a product. But when I take the derivative, I clearly had a product up here also. But when I take the derivative of this part, then I have the chain rule. Wow. So you just need to practice these in order to be able to figure that out. Just know, the more you do, the better you'll get at this. So the product rule is the first times the derivative of the second. So the derivative of the second would be this bad boy here. Bad boy, I don't know why I said that, that's weird, but whatever. The derivative of the second. So 1/2 is my outside function, that's my exponent. My x plus 3 is on the inside, that's my inside function. Wow. Take the derivative of the outside. Leave the inside alone. Times the derivative of the inside. The derivative of x plus 3 is just 1. So I did first, derivative of the second, plus the second, times the derivative of the first. And this is actually the derivative right here, so I could technically stop if you just asked me, or if I just asked you probably, what's the derivative of this function? This is it. But I'm going to keep going a little bit, and I'm going to rewrite this so that I don't have any negative exponents. So I'd have 5x over 2. This x plus 3 to the negative 1/2 would become x plus 3 to the positive 1/2. Or I could have said the square root of x plus 3. Plus, here I've got x plus 3 to the positive 1/2. Then I had this 5. And just because I can, because I know that there's some times where this would be the case. If this were a multiple choice question, the answers might be that this was all together as a single fraction. So if that was the case, I would want to put this over 1. And then to get a common denominator, I would need this one to have 2 times the quantity x plus 3 to the 1/2. If I did that in the denominator, I would need to also do that in the numerator, or multiply that in the numerator. Because now that's just some crazy form of 1 that I'm multiplying by. Now I can say f prime of x is equal to, and I have a common denominator of 2 times x plus 3 to the 1/2 power, or you could have said the square root of x plus 3. And then in the numerator, I would have 5x plus 5 times 2 is 10. Here I would have x plus 3 to the 1/2 times x plus 3 to the 1/2. So remember, if you have something like x times x, how you get x squared? Because when I have like bases, they're both x, I can add the exponents. Same idea over here. So x plus 3 to the 1/2, x plus 3 to the 1/2 would have the same base of x plus 3. So I add the exponents. X plus 3 to the 1/2 times x plus 3 to the 1/2, 1/2 plus 1/2 is 1. And you could take a 5 out of here and factor that out, but I'm going to leave this. It's a single fraction. Leave my answer like this. Let's do another one. Look at this one. I've got sine. Sine of x is normally what I have, but this is sine of a whole function in here. Very exciting. So wow, I've got a chain rule going on. And then also on the inside, you can see there's a quotient rule. So you can do these rules, like a bunch of them at the same time. Hooray! So g prime of x. I'm going to take, if this is a quotient rule, I take the derivative of the outside. So the derivative of sine is cosine. I leave the inside alone, times the derivative of the inside. The derivative of the inside is going to be a little bit more work because I can see it's a quotient. So what's the quotient rule again? Bottom times the derivative of the top minus top derivative of the bottom over the bottom squared. So I'm going to say bottom times the derivative of the top. The derivative of 2x plus 1 is just 2. Bottom derivative of the top minus top derivative of the bottom over the bottom squared. So I did the derivative of the outside, I left the inside alone, times the derivative of the inside. And if we wanted to simplify this, we could. Do we want to? Nah, we don't have to. If you wanted to do this and put it all together, I will put this at the end, that g prime of x is negative 7 cosine 2x plus 1 over x minus 3 over x minus 3 squared. Because this ends up becoming, this whole thing ends up becoming negative 7 over x minus 3 squared. Just so you know. Ooh, it just got super windy outside. Crazy. You know what super windy times call for? More calculus. Is that not what you were thinking? It's a good time for more calculus. It's always a good time for more calculus. Look at the room on this one. So much room to write. To find h prime of x. I should have actually rewritten this first. This is the same thing as 2x plus 5 to the 1/2 power over x minus 3. And I can see right in this one, I've got a quotient. So let's do the quotient rule. What is the quotient rule again? Bottom times the derivative of the top minus top derivative of the bottom over the bottom squared. So bottom, the derivative of the top. This is very exciting. Wow. I've got the chain rule. I have a function within a function. So 2x plus 5 raised to the 1/2 power. So I'm going to say 1/2. Leave the inside alone. Times the derivative of the inside. So now I'm going to check and make sure I'm good. So I did bottom, derivative of the top, minus the top. Derivative of the bottom would just be 1 over the bottom squared. I want to make this look a little bit nicer just because there's negative 1/2 in here, and I have so much room. Why not use it? It's 1/2 and 2 would cancel out. This would become x minus 3 over 2x plus 5 to the 1/2 power. This is a negative exponent, but it would just be the denominator of the numerator, just for this part. You can't just automatically like take it down to the real denominator. Minus 2x plus 5 to 1/2 power. If I were solving and I want to know like what the slope of the tangent was at a point, let's say 5, I would substitute in 5 right now. But because this is just h prime of x, again, if this were a multiple choice question, I just want to make sure you would know how to simplify this further. There's a 2x plus 5 in the denominator of the numerator. To get rid of that, I would need to multiply everything in the numerator by 2x plus 5 to the 1/2. And if I did that here, I have to multiply the denominator too. And the reason is just because 2x plus 5 to the 1/2 power divided by 2x plus 5 to the 1/2 power, some weird form of 1. I'm going to distribute this. I have h prime of x. It's equal to 2x plus 5 to the 1/2 power, and if I distribute this, they would just cancel out. The 2x plus 5 to the 1/2 divided by 2x plus 5 to the 1/2 would just be x minus 3 would be the only thing left over. Minus, here 2x plus 5 to the 1/2 times 2x plus 5 to the 1/2. It's that same situation, like the x times x is x squared, because I'd be adding the exponents together with like bases. I'm adding the exponents here, This would be 2x plus 5, the first power. Make sure that you put the parentheses around this since it's subtracting this whole term. In the denominator, I've got x minus 3 squared, 2x plus 5. If you try to simplify this and you went like this and then like this and just got rid of stuff, somewhere a bunny died. Maybe two if you did that twice. You don't want to be responsible for that. So what I need to do is turn my numerator into some products or something if I want like a product in some way, if I was trying to simplify. If I did this would be negative 2x minus 5. So x minus 2x would be negative x. Negative 3 minus 5 would be negative 8. X minus 3 squared. I can't do anything with that. I can't do anything with this. So I think that's where I'm going to leave it. And if you want to change this into square root of 2x plus 5, good. Okay, so we just did algebra. I know you were thinking, next, I wish I had a table or a graph. You have a graph next, so your really wishes have been granted. You are welcome. Over here it says, given the graph of h of x pictured to the right. Right now this graph stinks. So much better. What does it smell like, do you ask? Does it smell like snoo? I'm hoping you asked, what's new? Then I say, not much. What's new with you? Such a good one. Okay, moving on. This is h of x over at the right. Find the equation of the line tangent to the graph. Oh, the equation of the tangent line. It's like coming back to an old friend. What do you need for the equation of the tangent line? A slope and a point. And it says tangent to the graph of p of x. So I need the slope and the point of p of x. So the slope of the tangent line, also known as the derivative, would be p prime. If p of x is equal to h of x, but it's the square root, so this is always the 1/2 power. Right now I've got a function within a bigger function. Wow. So to take the derivative, I would say derivative of the outside. That's where this 1/2 something to the negative 1/2 is coming from. I leave the inside alone. Times the derivative of the inside. I'm going to rewrite this only so I don't mess it up. So p prime of x would be h prime of x is only in the numerator. In the denominator, I would have 2 over h of x to the 1/2 power, also known as the square root of h of x. If I substitute in p prime of negative 4, I would have h prime of negative 4 over 2 h of negative 4. H prime of negative 4. If this is a graph of h of x, h prime is the slope of the tangent at x equals negative 4. So I'm going to go over to negative 4, and I can see I've got a straight line going on here, which is nice. So I check for the slope. So I'm just going to count to the next point that I kind of see goes through nicely. I go down 1, right 2. So this would be negative 1/2 is h prime of 4 to h of negative 4. This is just the function value at negative 4, which is 4. That means p prime of negative 4 is negative 1/2. This is divided by, I'm going to write this here to save some room, 2 times 2, which is 4. So instead of trying to take negative 1/2 divided by 4, what I'm going to do is I'm going to say this is negative 1/2. Instead of saying divided by 4, I'm going to say times 4 over 1, which would also be known as negative 1 times 4 is negative 4 divided by 2, negative 2. So right now I know y minus y1 is equal to m. There it is. My m, my slope in the tangent, is negative 2. The next thing that I do need to know is my point, and this was p of negative 4, and I'm going back up to this square root of h of x, square root of h of negative 4, which we just said this, but looking again just to make sure we were right, h of negative 4 was just 4. The square root of 4, because this was given to me, I didn't introduce the square root, I can just say this is positive 2. So if I'm saying y minus 2, that's my y value, from this point. X minus negative 4. Ta-da! Were you hoping that we would do one more page? One more? Okay, okay. You don't have to push. We'll do one more. And were you hoping that it was a table? What? We did algebra. We did a graph. And now we get to do a table. We get to do it. It makes it sound so much better if you say it that way. So really most things in life, when you say, I get to do this thing instead of I have to do this thing, your world is just better. So we have this table and it says, let f of x and g of x be differentiable functions. That's nice because in everything we did, the product rule, the power rule, the whatever the rule was, the quotient rule, the chain rule, all of them had to do with if a function is differentiable and then I put this function with another function, then the result will be differentiable. So we're good. We can use the product rule, the chain rule, and the quotient rule. All those are good. And the power rule. It says it is the graph of h of x equals f of g of x. Wow. There's a function within a function. Increasing, decreasing, and our relative max or min at x equals 3. So what I want to do is I want to figure out, well, if I want to know increasing or decreasing, what I have to do is find the derivative. Because I know if the derivative is positive, that means that my function is increasing. H of x would be increasing, negative, decreasing for h of x. And min or max, it would be potentially occur whenever the derivative is 0. So then I'd have to do a little bit more work with the table. But let's just see. H prime of x. This is a function within a function. Wow. So I take the derivative of the outside, leave the inside alone, times the derivative of the inside. Once I do that, I would say h prime of 3 will be f prime of g of 3 times g prime of 3. Whenever you're working with a function, a composite function, you're working from the inside out. So you're going to find out what is g of 3. G of 3 is 4. And then you would say, okay, well this would be h prime of 3 would be f prime of 4. F prime of 4 is 8. G prime of 3 is 4. 8 times 4 is 32. Oh man, that's a big number. That's okay. That's the right number. So if this is, oh wait, I have 48. So let's see if I messed up something. G prime of 3. G prime of 3. Oh, guys, silly me. Look at this. It's 6. G prime of 3 is 6. 8 times 6 is 48. Okay, this number is also large, but now it's the correct one. We did it. We found our mistake. And in our house, if you make a mistake, you fix it. Hopefully that's the same in your house. So, or you do your best to fix it. So 48, 48 is a positive number. So that means if I have a positive slope for a function, that means my function is increasing. So if h prime of 3 is positive, that means h of x is increasing at x equals 3. So what that means is h of x is increasing, and you have to make sure that you say where, so at x equals 3, and my justification is as h prime of 3 is greater than 0. Let's do this one next. P of x is g of 2x. That's a function within a function. Yes. And it says what is p prime, which means that I need to take the derivative. Woo woo! My inside function is just 2x. My outside function is g of something. So what is the chain rule again? Wow. Derivative of the outside. Leave the inside alone. So g prime, leave the inside alone, times the derivative of the inside, which p prime of 1 will be g prime of 2 times 1, also known as 2, times 2. G prime of 2, g prime of 2 is negative 1 times 2. And again, negative 2. This is p prime of 1. I don't know why that's so big on the side. Maybe I need to put a smiley face or something. I don't know. Then I have another problem. It's the last one. Well, there's going to be one more that I'm going to give you just so you can think about it. But if q of x is equal to the square root of f of x plus g of x, what is q prime of 4? That means I get to find the derivative. And then I'll answer the rest of this question in a second. Q prime of x. Actually, I'm going to write up here q of x. And I'm going to rewrite this, because anytime I see a square root, I want to rewrite it first, so that it looks like something raised to the 1/2 power. And right now you should be able to see that something raised to the 1/2 power is my outside function, and then my inside function is actually two functions anyway, it's adding them, but f of x plus g of x. So when I take the derivative of a composite function, wow, I take the derivative of the outside. I don't know why I look angry when I do that. Wow. So if you were scared, don't be scared, I'm not angry. 1/2, keep the inside the same, because I'm taking the derivative of the outside, so derivative of the outside, leave the inside alone, times the derivative of the inside. The derivative of f of x is just f prime. The derivative of g of x is just g prime. So if I'm doing this here, my derivative is just f prime plus g prime. But if I just did this, I would be wrong. What did I forget? Boom, parentheses. You have to make sure, because you're taking f prime of x plus g prime of x, multiplying it. Then I'm going to rewrite this q prime of x. In the numerator is this f prime of x plus g prime of x, which you could keep the parentheses, but they are assumed if you're just, that's the only thing in the top of a fraction. 2. In the denominator, if you want to write it as just the 1/2 power, you can down here, because we're switching it. Or if you want to say, you know what, I know that this is the same thing as f of x plus g of x. Square rooted. I'm intentionally changing these back and forth because you should be able to talk about them as something raised to the 1/2 power or the square root. Q prime of 4 would be f prime of 4 plus g prime of 4. 2 square root of f of 4 plus g of 4. F prime of 4 is 8. Can you see it? Nope, there it is. Plus g prime of 4 is -2. F of 4 is 1. G of 4 is 7. So I have 8 minus 2 is 6 over 2 square root of 8, which you could leave it like that, or you could say, well, 6 divided by 2 is clearly 3 over square root of 8. Don't rationalize this, just keep it that way. So I say q prime of 4 is 3 over root 8. And then it says, what does this value say about the graph of q of x when x equals 4? This is a positive number. So what does that say about q of x? Q of x is increasing as q prime of 4 is greater than 0. And you know what? I should say one more thing, because I can't just say increasing all over. I need to make sure that I say at x equals 4. So you could say q of x is increasing at x equals 4, or at x equals 4, q of x is increasing, and the reason is q prime of 4 is greater than 0. Okay, so this, I said this was the last problem, but I just want you to think about one more. If you had a problem that looked like this, q of x is equal to there are two different versions of the test that I usually give on this, and on one version, somebody gets something that looks like this, and on the other version, somebody gets something that looks like this, and you have to take the derivative, and that one even has a table. I don't know if you'll have that test this year. I'll let you know as I know. But I think I'll use more AP Classroom, but maybe I'll find this question because I really like it. Q prime of x. Q prime of x is going to be, this is the same thing, by the way, as f of x. Oh, sorry, I should change this. I meant this to be times g of x. If you're like, oh, that looks like the same problem to me. That's because it was the same problem. But this is on one version of the test, that was on the other one. This is f of x times g of x raised to the 1/2 power. If I take the derivative, I'm still using the chain rule. Wow. There's still a function within a function. I still do 1/2. My new exponent is -1/2. I still leave the inside alone. But Now when I do the derivative at the inside, I now have a product, which means it's not just f prime of x times g prime of x. That's not a thing. The derivative of the inside would be first times the derivative of the second plus second times the derivative of the first. That's a lot. And if you were to rewrite this, just because I can't help myself, in the numerator would be f of x g prime of x plus g of x f prime of x over 2 root f of x times g of x. Okay, I'm sorry. I couldn't resist that. I was going to not do the rest of it, and then I just felt like, yeah, just couldn't stop myself. I'm sure you like that too with math. Thanks for being awesome. I appreciate you. I appreciate all that you're doing. I hope that you feel like you're learning a ton, because I think you are. And that makes me really happy. I hope it makes you happy too. I hope you are well wherever this video finds you, and your day just keeps getting better. Thanks for being awesome. If you need anything, let me know.